Hello everyone and welcome back to another video, and today we are going to solve next permutation. This specific pattern or this specific problem can be a part of another problem, and this could be asked in terms of linked list as well, but the theory behind this or the logic behind solving these problems always remains. So first of all, let's read our problem statement and try to understand what we are trying to solve here. So the problem statement says a permutation of an array of integers is an arrangement of its member into into a sequence or linear order. Okay, so they have given us an example. So for example, they have given us an array of 1 2 3. So the following are the permutations: 1 2 3, 1 3 2, 2 1 3, and 2 3 1 and 3 1 2. So these are all the possible permutations of our given array. Our question is not finding all the possible permutation. However, that is a great problem to solve before attempting this problem, because the brute force solution of this problem comes from that solution. So basically the time complexity for finding all the permutations would be n into n factorial. That's a different topic. If you want, I can make a video on that. You can comment, you can write that down in the comments. But basically what we can do is we can find all the possible permutations and just return the next permutation, right? So basically if our input was 213, we can return the next element, which would be 231, right? So that would be like n into n factorial, a terrible time complexity and definitely not acceptable in terms of interview, right? So we can actually solve this in O of n time complexity, and the solution is quite simple. And like you can see here, right, the replacement must be in place and use only constant extra memory. So there are some extra restrictions from Leetcode. So they have given us an example, so we have already discussed this, but they have also given us a edge case, you could say, right? So the next permutation of 3 to 1 would be 1 to 3. Okay, so you could just remember this one case where if our array is sorted in reverse order, we just have to reverse it, right? We can just kind of sort it in the linear order. So there is no point in like, if you know, right, if you know the array is sorted in reverse order, we can just reverse it instead of sorting it, because that would be n log n time complexity, and reversing is just O of n time complexity, so that is better. And how are we going to know our array is sorted, right? So that is part of our algorithm which we are going to use to solve this problem. Okay, so I hope the question is clear, right? I will just take a different example, not 1 2 3, because I think taking just 3 elements is not a good enough example to explain my point. Okay, so now we are back in whiteboard, and now I think this is a great example to make my point, or to show the algorithm that we are going to use to solve this problem. There are just 3 steps that we have to remember, or maybe 4 steps if you consider the edge case, right? The 3 steps are, first step is step 1. Okay, find the breakpoint. Okay, find the break point. If you are making notes, I think you should write this, or I will try to attach a PDF if possible. Okay, so find the breakpoint. Now what is the breakpoint? That's the question, right? So basically we will go from n minus 2, right, because we want to check from the second last index. Okay, so we will go from n minus 2 till 0th index, and we will try to find an element or an index I where our number at index I, okay, so number at index I is smaller than I plus 1, right? So in our case, which is what is that element, right? 2 is not smaller than 1, 3 is not smaller than 2, 4 is not smaller than 3, 5 is not smaller than 4. However, 3 is smaller than 5, right? So our breakpoint index would be 3, right? So now we know our breakpoint is equals to 3, or index, in terms of index it would be 1, right? Now this was the first step. Okay, now what we have to do with the breakpoint? Now we have to again traverse the array in this direction from the last element to the element after our breakpoint. Basically we have to traverse the right hand side of our breakpoint. Okay, so basically this whole section, and we just have to find an element, right? We are going, remember, we are going in this direction, and we just have to find the first element which is greater than our breakpoint. In this case that would be 4, right? And we have to swap these two elements. Okay, we have to swap these two elements, right? So what we have to do, second step, is find the first element traversing wait, which is greater than breakpoint. Okay, breakpoint element, traversing from right to left, or in other words from length minus 1, that is the last element, to breakpoint index, right? Index plus 1. So in this case our length would be 0, 1, 1, 2, 3, 4, 5, 6, 7. 7 minus 1, 6. It will go from 6 to 2, right? And check which is the first element greater than our breakpoint element, which is 4, right? And we can just swap these two elements, and once then swap those elements, right? Swap those elements. After performing the step number 2, we have 1, 4, 5, 3, 3, 2, 1. There is one thing which helped me understand the intuition behind this approach, or intuition behind this logic, and that was, we are basically just taking a larger number, right? For example, let's just take a smaller example like 1, 2, 3, most basic example, right? So what would be the next permutation? It would be 1, 3, 2. So we are just taking a large number, substituting it with a smaller number, right? On the left hand side. So what happens is, we are basically finding the next element using only these numbers, right? Kind of. And but one problem is, now the one step is missing, right? One final step is missing here, and that would be like our step number 3. Step number 3, reverse the right hand side section of breakpoint. Okay, we will just, what we have done is, first step was finding the breakpoint. What is the breakpoint? The element or the index where nums of I, right, the element of ith index is smaller than element at I plus 1. Okay, where I is our index, and once I would be our breakpoint, right? We found the breakpoint. What was our next step? Our next step was finding an element traversing from the last element to till the elements just before the breakpoint or just after the breakpoint, right? Breakpoint plus 1 index, and finding an element which is greater than our breakpoint, element at our breakpoint. We found that 4, and then we swap those numbers, right, which gives us the next greater element. But there is a one final step. We just have to reverse the elements in the right hand side of the breakpoint. Okay, we just have to reverse the numbers in the right hand side of the breakpoint. Once we have done that, we get our result, right? This is our result. So I guess this algorithm makes sense. Now let's move on to the coding part, right? one thing I would do is just write private void swap, because we are going to need this method anyway. So I would like just write this integer temp is equals to nums of I and nums of I will be equals to nums of j will be equals to temp, and that is our swap method, helper method. And now we are going to write our main algorithm, right? So breakpoint, and breakpoint I will be taking initially 0 or first index. After that, what can we do? So we can go from integer index equals to let's just do one more thing. This is a nice habit. If we are using some property again and again, we can just store it in a variable, right? Instead of typing nums.length again and again, that just introduces a point for failure. You can mistype that. It's not a big deal, but still it's better to store it in a variable. So let's just say length minus 1 and I is greater than or equals to 0 and I minus minus, and while this condition is true, if, or sorry, let's do one thing, I minus 2, if nums of I index, if nums of index is smaller than nums of index plus 1, right? Then we can say we have found our breakpoint, right? And we can just assign it, and since we have found our breakpoint, we can just break out of the loop. So if you are keeping track, this operation would be O of n time complexity, right? Still O of n, and we are only using constant space because we are just using variables. Remember, that was one of our prerequisites to solve this problem, and it was mandated by Leetcode only, not the rules I am making. Anyways, so moving ahead, this was step number 1, right? Step number 1, finding the breakpoint. Now that we have our breakpoint, I think we should handle the edge case, right? If our breakpoint is equals to -1, right? Let's suppose our array is sorted in reverse order. So what do we have to do? We just have to reverse our entire array, right? uh, Basically, yeah, we just have to reverse our entire array. Let's pass that responsibility to a helper method again, and we can just return. We don't have to do anything else. Once if we know that our array is sorted in reverse order, we can just reverse it, and basically sort it in a ascending order, and we can just return. Okay, so let's write a helper method for that, and private void reverse integer array nums, and yeah, what are we going to do? We will say integer left equals to 0 and right equals to nums dot length minus 1, and while our left is less than right, we will just swap those elements, right? Swap nums left plus plus, right minus minus, and yeah, this helper method will swap our elements. Now we have this helper method, we have this helper method. Okay, we have a couple of helper methods, basic stuff, right? You know how to reverse, you know how to swap the numbers. That's not part of our algorithm. That's just some helper methods to make our code look better, more modular. Yeah, so moving on, next step is so let me just write in the comment, handling the edge case where our array is sorted in reverse, right? Now let's come back to our core algorithm. What would be what was the next step? Next step was again looping from length minus 1 till our I is greater than breakpoint, not equals to but greater than breakpoint, right? And we have to find if a certain number nums at index is greater than nums at breakpoint, right? We can just swap those elements. Okay, so swap nums index breakpoint, and we can just break out of this loop. Now this was step 2, right? If you remember, this was step 2. Now the final step, or step 3, step number 3 is basically reversing the entire right hand side of the breakpoint. Okay, so we can just call a reverse helper method, pass nums. Okay, and let's just do one more thing. Let's just take integer left and integer right as input parameters, instead of taking them as you know okay. So what we can do here is, we can pass it as 0 and length minus 1. And now here what we can do is, we can pass it as breakpoint plus 1 and length minus 1. So now this should do the trick. So there were a few mistakes in my code, right? Like I was declaring it at index, and I was using I here, and there was the same mistake here as well. Apart from that, we have to take -1 as a default value, right? Because we will never hit this condition, right? So we need to know that our array is in descending order, sorted in reverse. Okay, so that's why we can just use -1 as a default value, and now it should, our code should work properly. Yes, so let's see, this works, accepted, and now let's submit the code. Yeah, as you can see, we are faster than 100% of the users with Java, and quite efficient in terms of memory as well, because we are again using constant memory, and the time complexity is also O of n, which is, I think, the best achievable time complexity here. There are just 3 steps which you have to remember, and if you remember those 3 steps, the algorithm or the code is quite simple. Okay, so I hope this helps, and I will I'll share this PDF on my LinkedIn actually, and I will attach the link to that post, so you can also follow me on LinkedIn as well, where I will be sharing the notes for this problem, the PDF, this PDF, specific PDF. If you have any feedback or any comments, please do let me know in the comments. I will make sure to read those comments, and try to improve my quality of videos. So thank you, and let's meet in my next video.